Welcome Earth Science students to the last video of our unit on climate. Just a little bit of review first to get things started. Things that you'll need to know for the unit test. So what states are going to have a nice day according to the weather map? Okay, remember that high pressure systems, anytime they're above high pressure systems, that you're going to tend to have better weather. When you are along with that, you also have to think about your fronts. When you are below cold fronts, they kind of point in areas that are going to have worse weather. You can see here that in the southeast part, they're going to have thunderstorms. We're going to get snow up in the north part by Michigan and Wisconsin and Minnesota and into Canada. We're also going to get snowstorms by the other low pressure system. Remember, low pressure is going to bring bad weather most of the time, and it's going to be above those things. Okay, all the high pressure systems, when you're above the high pressure system, you're going to have relatively warm weather. What direction is the cold front on the right side of the picture heading? Let me find the cold front. Okay, so that's this blue one right here. This blue one that's cutting across Florida and the Carolinas and Ohio and that sort of thing. Okay, which way is that one going to be moving? Well, because of where we are, remember that weather always travels from west to east. So it's going to be pushing out towards the Atlantic Ocean. What type of front is being shown in the upper left-hand corner of the image? How do you know? If you look, that is going to be a warm front, just based on how it is shaped. It's red with a little half circle. Hopefully you guys saw that document that I posted last time. Okay, and remember, it's all dependent on how the fronts are drawn, and that can tell you a lot about the weather in that area. Okay, so moving on to our last topic, and we're going to be talking about climate change. Obviously, we can't talk about climate without talking about climate change. It's a very, very controversial topic politically and that sort of thing. What I'm set out to do is to give you the facts of how it's changing, what's changing it, and that sort of thing. Okay, so we're going to start off. How is climate different than weather? Okay, so first of all, climate, okay, before we get into this, climate is different than weather because climate is over many, many, many years. Okay, weather is like what is happening today. Okay, so what I want you to do is we're going to keep adding to this graphic about long-term, short-term, and natural causes and human causes of climate changes. Okay, changes that affect the whole Earth and its weather patterns over several seasons or years. Okay, what I would recommend is, if you're taking notes, is to draw this graphic. Okay, we're going to add certain things to each little box and talk about what they mean. So, first one, long-term climate change obliquity. Okay, so we had this video on obliquity already, I believe. I'll post it again in case you haven't checked it out. So obliquity, again, remember, is the tilt of the Earth. And remember, that tilt changes. It varies between about 23.5 degrees and forward and backward to like 21 and 24-ish or something like that. Remember that the tilt determines how extreme our seasons are. So yes, the obliquity does change our climate depending on if we have a more extreme tilt or a less extreme tilt. And this we call a long-term change because I believe it takes somewhere around 40,000 years for us to go in one complete cycle of obliquity, meaning like we go from 21 degrees all the way there and all the way back. I believe takes somewhere around 40,000 years. If you're curious about what the actual date is, you can look that up. Okay, so that was our long-term climate change. Okay, now we have short-term climate change. Okay, so tilt and orbit, go with that one that we talked about earlier. We're going to talk real quick about El Nino and La Nina. Okay, so let's get into those. Okay, so this is another video we already had. Okay, think about how tilt and orbit affect the seasons. Okay, so remember when we're tilted away, that is when we are going to be in our winter. When we're going to be in summer, we're going to be tilted towards. Okay, where we're at in the orbit also determines how long our days are. On a lot of your guys' quizzes, I wrote a lot of comments about making sure that you realize that it's warm because our days are longer and therefore we have more sun's energy. Okay, the longer our days, the more sun we get, the warmer it's going to be. All right, so El Nino, La Nina, two things we have not talked about yet. They take place in the Pacific Ocean. Okay, and I want you to watch this video on it. It's a very, very nice graphic and it explains it very well. It has to do has to do with the winds, the trade winds near the equator and how they affect the water. Okay, so just a very brief overview. Okay, under normal conditions, trade winds move west across the South Pacific. Low pressure near Australia, high pressure near South America. So in the low pressure system, or low pressure near Australia, it's warm, and high pressure near South America, it's cold. You get normal upwelling from South America because of the way the wind is blowing. Remember that wind causes upwelling. It pushes the surface water away, and then the cold ocean water that is underneath that surface water gets brought up to the surface. And because of the direction of the trade winds, that occurs in South America, whereas the warm surface water gets blown to Australia. All right, so in periods of El Nino, the trade winds are really, really weak and they actually switch directions. And so what ends up happening is that there's not enough wind to cause upwelling. And that means that the entire Pacific Ocean is going to be relatively warmer. Okay, but what this does is it leads to very stormy seasons for North and South America because of all the evaporation of water that's going up into our atmosphere, causing more water to collect, and it causes more thunderstorms and that sort of thing. Okay, and if you imagine now, the trade winds are switching direction, so they're blowing towards the Americas and not towards Asia and Australia. In this situation, there is no upwelling because of the weak winds. Okay, La Nina is exactly the opposite. This is where the trade winds become really, really strong. Okay, this makes the entire Pacific Ocean cool because it causes a lot of upwelling. Okay, so it's going to push so much water towards Asia and Australia that it's going to bring up a lot of cold water and make the entire ocean cold. Okay, so that's La Nina, El Nino, and then normal conditions. Okay, here's a graphic of how that happens. So normal conditions, you'll notice that we have cold areas over by South America, then we have warm areas by Australia. Okay, El Nino's in that bottom left, where the whole ocean is more warm. The wind is blowing from left to right there. And this is what causes more thunderstorms for North and South America. And then, like I said, for La Nina, we have really strong winds pushing right to left. Okay, right to left. And what that does is it pushes all the warm water to Asia, and we have massive upwelling. Okay, how does this impact Colorado? Okay, I'll post this link also in my post so that you can check it out. We do get affected weather-wise. We get more storms in certain times because of this as well. We are close enough technically to the coast to get a little bit of residual effects of these two things. Okay, so we've done long-term obliquity, short-term tilt and orbit, short-term El Nino, La Nina. Now let's get into natural causes. So we have solar activity, so that's the activity of the sun, and volcanoes. Okay, so natural changes happen with Again, if you remember back when we did the unit on the sun, okay, when the sun is more active, okay, our temperatures can increase, our weather can be more extreme. It all depends on the amount of cosmic rays coming into us. When it's less active, then we have less. Okay, just like we talked about at the very beginning of this class when talking about the sun and sunspots and solar flares and all those things. Okay, if you remember, we did this exact graphic talking about sunspots and the amount of solar radiation. We did it as a lab, I believe, and that's what that graphic is talking about. Okay, other natural changes. We're talking about the solar radiation coming in, and obviously you guys can see that there's a bunch of different things that happen. Some of it is absorbed by the atmosphere, some is absorbed by the surface, some is reflected, some gets scattered by clouds. Okay, all of these things occur every time solar radiation comes into the Earth's atmosphere. Okay, now, where volcanoes come in is when they erupt and they emit this gas and all of this ash into the atmosphere. Okay, they're effectively putting these greenhouse gases into the atmosphere, and what happens is it can block out the radiation coming in from the sun. And so whereas a lot of people might think, oh, well, it's trapping the heat from leaving the earth, it actually does the opposite. It actually is so bad that it reflects all of the solar radiation so that it never actually even reaches us. And this causes a massive cooling effect on the earth in that region. Okay, so wherever the ash pattern of this volcano are going to see drastically colder temperatures because of how the atmosphere has to adapt to what's been introduced to it. Okay, one of these examples is Mount Tambora, which was a volcano in Indonesia. It erupted in 1815. And just to give you a scale, we talked about Mount St. Helens when we were doing volcanoes. Okay, this is way greater than Mount St. Helens. Okay, this was the biggest eruption in human history that we know of. Okay, in recorded human history. Okay, the ash cloud, as you can see in the top right picture, spread from Indonesia all the way to Africa, all the way across Europe, and even ash was found in parts of Canada and Maine, of what is today Maine, obviously. In 1815, not everything was completely settled and that whole thing, but either way, hey, it reached all the way to there with their ash clouds, and all of these places were affected. Okay, so I already showed you this graphic as well about how the climate is affected in years, days, hours, weeks afterwards. Okay, in fact, this caused what they call the Little Ice Age. Okay, across Europe. In the June of 1816, there was a sudden snowstorm due to the volcanic eruption covering most of Europe, and it became known as the year without a summer. Okay, so even in the middle of June, when we're tilted towards the Earth or towards the sun, okay, and we're supposed to be having warm weather in the northern hemisphere because of this volcanic ash and this all these gases in the atmosphere reflecting the solar radiation. Okay, it was so cold that they had snowstorms. Okay, during this year it was so depressing. That's when Mary Shelley wrote Frankenstein. Grain couldn't ripen under these conditions, so there was a massive famine for most places, and it would go from 95 degrees to freezing within hours, which was a brutal struggle for the people and the starving livestock. So as a result, the bicycle was invented during this time, mostly because people Sorry, my computer was glitching. Okay, so people during this time, okay. All right, that's weird. Okay, either way, hopefully you guys can't see what's happening on my screen. Okay, but as a result, yeah, the bicycle was invented. I forgot my train of thought. Okay, so yeah, the bicycle was invented during this time. Very, very weird summer to have normal 95-degree weather and then freezing cold and kind of like Colorado weather sometimes in the spring. Okay, so moving on, last part, human causes, deforestation, and emission. Okay, so we cut down trees mostly for lumber, for paper, for all kinds of things. Okay, avoiding deforestation is better for the climate than reforestation. It's actually better to not cut down the trees in the first place than to plant new ones. First of all, by burning them, you get immediate carbon emissions from deforestation, gradual carbon capture and accumulation. Once you replant them, okay, it takes a while for them to get back up to what they were taking in as far as carbon. Remember, all of this goes in with the carbon cycle, and carbon in the atmosphere is what helps trap the solar radiation and causes our climate to warm up. Okay, so that's what they're talking about with this deforestation, and the more trees we have, the more carbon that gets taken out, and the less gets trapped. Okay, and then second is emissions. Okay, we put up here our graphic on certain emissions based on carbon dioxide, methane, nitrous oxide, those sorts of things. You can go through the breakdown. I'm not just going to read it out to you. But again, remember that these emissions are what contribute to our greenhouse effect of trapping our solar radiation to the Earth, causing our Earth's temperature to warm up. All right, so that is all I have for you for climate changes. Make sure that you have them written down as long-term, short-term, natural causes, human causes, as far as climate changes go. Okay, we have a very, very short assignment for you, and then we have the unit test. Make sure that you get that unit test done as soon as possible. Stay on top of your stuff. We only have one more unit to go. Just an FYI, the last post that I will make, I believe, is on May 14th. Yes, May 14th. That will include the last lesson and the final. The final will be due by Sunday. That's when I'm hoping all of your makeup work is in. Okay, and then I will be posting final grades either Monday or Tuesday that week. Okay, we are very, very rapidly coming to the end of the year. Okay, so make sure you're staying on top of your stuff, staying on top of your grades. As always, thanks for watching.